right. Hey, how's it going, guys? Happy Monday or Tuesday. And you know what? I'm patting myself on the back here. That's right. I'm patting myself on the back because of that lesson on Friday. If you watched it, if you did that worksheet, I think you're in pretty good position actually just to do section 6.4 by now. So you know what? In case you haven't done it yet, I would do this first. I'll see you on the other side of this little introduction here, but just take 2 minutes, maybe pause this video, take 2 minutes just to read through section 6.4, pages 262, 263. Just make sure everything that we talked about with our little worksheet the other day where we're cutting up right triangles, 45, 45, 90-degree triangle, 30, 60, 90-degree triangle. Make sure as many things are connecting as possible with this before we get into it. So give it a quick read through and then we'll go through it briefly before you get into all your problems that you have to do Monday and Tuesday. See you guys on the other side. We are in section 6.4, special right triangles. This is what today is going to be about today, Monday and Tuesday. Today's about writing out the theorems, getting them in your notes because, we talked about them. We have made some connections. You had some summary statements here. And then getting lots of practice with them. There are plenty of great problems in this textbook that I'd love for you to figure out. Definitely some challenge problems at the end that maybe not everybody will get to, but I think are good to look at and will be good for your groups to kind of go over and share the answers on the Jerry board on Wednesday. All right, so I'm going to put up here the first slide we're going to look at here, which is really just what you read through before. Let's practice this real quick, though. 45, 45, 90-degree theorem. That's what we have. That's what you can call it right here. And that is the isosceles right triangle theorem. Of course, we have two 45-degree angles in the same triangle. It's going to be an isosceles triangle, right? Because we have two congruent angles. But if they're 45 degrees, all we get is 90 degrees left. So this is an isosceles right triangle. In fact, we should just call this 45, 45 triangle. That's all we need there, okay? Big thing here, right? We've proven it out. We've done it before, but my friends, we got this. It would be n squared plus n squared equals c squared. 2n squared equals c squared. Take the square root of both sides. You would get n root 2 equals c. That's what it's all about. So let's see here. See if you can do this. Just do this. Maybe pause the video take a second. Maybe pause the video, and we got some examples here. These are from the textbooks. We'll see if you can do them on your own, okay? Ready, set, go. Take it away. Take it away here. It said 2 minutes, but I'm only going to give you 15 more seconds, and then we're going to write out the answer because I think you got these. Did you do it? Did you do it real quick? This is where we get to geometry. Nice and easy. Maybe geometry didn't have to be so hard. 12 root 2. There's your answer right there. You can do it quickly in your head. This is 12. That's 12. Right? Because 45 here. These are congruent. These are congruent. These are congruent. This is 12. 144 plus 144 is 288. Square root of 288 gets simplified down to 12 times root 2, right? Because it'd be 2 times 144. Anyways, nice and quickly. The harder thing is this one right here. The harder one is B, where you got the hypotenuse, and that's getting the x right here. Do you remember the shortcut? We got a shortcut for this that I told you about here. That's right, 4 root 2. 4 root 2, there it is right here. Because the hypotenuse is always root 2 times longer than a leg, right? Than a leg for the 45, 45, 90-degree triangle. Our given premise is our triangle is a 45, 45, 90-degree triangle. Then we can deduce that the hypotenuse is root 2 is times as long as the leg. So here, simply what we need to do is divide that hypotenuse in half and then tack a root 2 to it because, hey, if we did 4 root 2, we can check our answer, make sure we got it right here by multiplying by root 2 again. Well, that's just going to equal 4 times root 2 times root 2 is 2. So just 4 times 2. And that equals 8. You can, of course, do it the long way, too. If you want to do it the long way and practice that, I'm just trying to get your feet wet and you practicing. And the key is to be practicing. That's why I get a whole bunch of problems later. So one way that you might have actually solved this originally was like reasoning through it. Well, this x, right, x times by root 2 would have to equal 8. So maybe you did it this way. Perhaps you did it this way. What can I do to solve for x? Well, I can divide both sides by root 2, right? Those would cancel out. Divide by root 2, and then, my answer here is not going to be 8 over root 2 because I got to do what? Rationalize the denominator. So here I would have to multiply by root 2 over root 2. Remember, I multiply this by a 1 in disguise. It remains the same, and our value of x doesn't really change. So 8 times by root 2 over, well, root 2 times root 2, right? The numerators multiply together, denominators multiply together, and that's how you can simplify fractions. Then you got 8 root 2s split 2 ways. So that means you got 4 root 2s total. All right, so you could do it the long way, right? You could do it here, maybe practice it that way, but hopefully you get Mr. Fortin shortcut there because it's worth working towards. How does the hypotenuse relate to one of the legs in a isosceles right triangle in a 45, 45, 90 degree right triangle? Well, it's just going to be half that hypotenuse times by root 2. That's your shortcut to get your answer real quick. Hey, let's move on. This is going pretty well. Let's move on to the next one right here, which is going to be practicing out the other special theorem that I'm hoping is in your notes by now, right? Another special right triangle has acute angles measuring 30 and 60. This is the 30, 60, 90 degree triangle theorem. In a 30, 60, 90 triangle, that's our given premise. This is what we got here. The hypotenuse right here, AB, is twice as long as the shorter leg, right? Right here, twice as long as this. And the longer leg is root 3 times as long as the shorter leg, okay? So one thing that I maybe want to point out real quick here is that the reference point here is always the shorter leg. That's it. That is a tip to you to help out with these problems. You want your reference point, hypotenuse, okay, or hypotenuse. So let's let the shorter leg be x, okay? Let the shorter leg be x. Then the longer leg is going to be root 3 times that, root 3, x root 3. The hypotenuse is twice as long as that, okay? Because remember that. Hypotenuse would be the same as twice the shorter leg, because if I just doubled my 30, 60, 90 degree triangle, I would have an equilateral triangle up here, right? 30 plus 30 is 60, and then I have 60 left here, right? It'd be equilateral if I doubled it. So anyways, this is 2x, that's x root 3 for the long leg. So I always, in these problems like this, I always go to the shorter leg first. Even if I know what the hypotenuse is and it's asking me for the longer leg, just take a detour. Divide by 2, and then multiply by root 3, right, to get us to your longer leg here. All right, whole proof, outline for proof solve here. Guys, we don't have to worry about that because we watched Mr. Fortin cut up some papers last week, and we got it good to go. So without further ado, you're on now again here. Take 2 minutes, solve these A and B, these examples. I know you may have read about them. Let's see if you can do them because you've got a lot of problems to do for homework tonight and Tuesday, do Wednesday. Teddy, pause the video, and then you got 2 minutes. Ready, set, go. All right, Mr. Fortin got impatient. He waited about 20 seconds, so he's going to have to speed that up. But I'm going over him right now. That's right. You better believe I'm going over him. 30, 60, 90. Very lovely. So another thing to notice here, too, the shorter leg in this one here, opposite the 30-degree angle. Okay, so that should remind us here, too, that we had that theorem, which was in a triangle. If one side of a triangle is opposite an angle that's larger than what another side is opposite, then that side opposite the larger angle is larger than the side opposite the shorter angle. Something like that, right? We know that this is the shorter leg. 6 is the shorter leg right here, okay? Because it's next to that 60-degree angle. Remember, this is like if I add here, that's how I'm going to get my equilateral triangle. So here, 6, x equals 12. There you go. You're good to go here because that's the hypotenuse. It's going to be twice the shorter leg. It's going to be twice the one where you have that 60-degree angle. Remember, here, shorter leg is going to be part of that 60 degrees because, yeah, we lopped off half of that side. And it's down there now. So there's 12. Okay, shorter side, nice. The shorter side is the one that's helpful for this here. Y is simply going to be 6 root 3. That's it here, right? Half the hypotenuse times by root 3, or really just root 3 as long as that shorter leg. Let's check out V. Let's make sure you got that one. Then you're going to go into your homework after this here. So now or even the longer leg. Oh, that's hard, right? It's hard when they give you the longer leg, right? It's hard with that, okay? Longer leg, where am I going to do my detour? I'm going to go to my shorter leg first. Okay, so write a little note to yourself. Write it down in your notebooks. Do that. Always get the shorter leg first, regardless if they give you a hypotenuse or if they give you a longer leg. Do it, okay? So something times by root 3 equals 8. Okay, let's do that here. Let's maybe set it up here. So if my longer leg is root 3 times longer than the shorter leg here, this statement is true. Whatever x is, I multiply by root 3, I get 8. So what do? I go from longer leg to the shorter leg here. What do I have to do? Well, I have to undo that multiplication, right? I have to undo that here. This is going to be root 3 times shorter than this one right here, or root 3, divide by root 3, right? It's the opposite of multiplying by root 3. So I'm going to divide both sides by root 3, divide both sides by root 3, and this takes some work, right? It takes some practice, takes some rationalizing of denominators here. So now we have 8 over root 3. What do I got to do? Oh, I got an irrational number in the denominator of this fraction. So I better get rid of that, shall we? Okay, so what I'm going to do here, I'm dividing by root 3 right here. I'm going to multiply this by root 3 over root 3, which is a 1 in disguise. Doesn't change what the value of x is, doesn't change what the right side of the equation is. So you multiply by 1, leave something the same. Okay, root 3 times root 3, that equals 3. And 8 times by root 3 is just 8 root 3. And that, in fact, is actually the most simplified we can do to write that answer. I mean, I could have written it as 2 2/3 root 3s, but that doesn't make sense. I mean, well, it's uglier, right, than this here. So I'll just leave it like this. 8 root 3s being split 3 ways. Leave it like that, okay? Maybe it's kind of like looking like an improper fraction. Anyway, that's going to help us because we're going to get to the hypotenuse right here. How do I go? So the beauty of finding the shorter leg first is what do I have to do to go from the shorter leg to the hypotenuse? I need to do what? I need to multiply this by 2, right? So I'm supposed to by 2 over 1. So my denominator is not going to change. Y is going to equal 16 root 3 over 3, and I got my answer. Is that an elegant looking answer? No, not really, right? When you're irrationalizing denominators, oftentimes your answer is going to be in a fraction, and you're going to have an irrational number in the numerator. That's fine. You just can't divide by an irrational number. Not allowed to do it against kind of the rules in mathematics we've all agreed to. I got together. No, I'm not old enough to get together. We had decided that. Got decided long ago. All right. Thank you for watching this video. Hopefully this additional lecture about this maybe helped clear up things a little bit, or at least got you a little bit more practice here before you jump into your problem sets, into real core work here over the next day or two. So you read section 6.4. I'm hoping if you watch this video, now here are your problems. You got pretty much all the classroom exercises. Like spend 10, 15 minutes on those. Written exercises, spend 10, 15, 20 minutes on maybe all these. Maybe it takes a little bit longer. Maybe it takes more like a half hour, I would say, on this one right here. And then you got some challenge problems at the end, which I think you can do, right? I think you can do here, okay? So you're looking at maybe 1 to 2 hours of work, potentially. 1 to 2 hours of work split between Monday and Tuesday. I don't think that's too much for most folks, but again, reach out to me if you're just like, I just got way too much going on. Just take care of maybe the written exercises 1 through 14, 19, 22, something like that. But you got to send me a message. Thank you for watching this here. Happy Monday. Message me if you have any questions.